Hey math fans, we're on section 1.3.3. Let's get started. The product of two complex numbers is found using the same method that's used to multiply two binomials. We're going to be doing double distribution. And some special things happen when you have something called complex conjugates. So a complex conjugate is a complex number that when you multiply it by this other complex number, it produces a number that's wholly real. So they have to be exactly the same except for one tiny difference. The imaginary component needs to be exactly the opposite. Here are some examples of some complex conjugates. So you can have 2 plus I as your initial complex number, but it will be 2 minus I that will be the conjugate. So in order to get the complex conjugate, you only take the opposite of the imaginary component. Here are some common errors and misconceptions. Example 1, find the result of I times 5I. Well, you multiply these two terms just like you would multiply any number with an ordinary variable, but just remember that when you have I, it can become I squared or I to the third, I to the fourth, I to the fifth, and we need to simplify. And remember, I squared is really -1. So we'll substitute -1 in there. So our final answer is going to be -5. Example 2 says find the results of 7 plus 2i and then 4 plus 3i. We are going to do double distribution here. So notice we're going to do 4 times 7. That'll create our first term. We're going to do 7 times 3i, and then we're done distributing the 7. Then we move on to the 2i. 2i times 4, and then we're going to go 2i times the 3i. Remember, I times I will get you that I squared, and we'll have to simplify that. So as we simplify this, we get 28 plus 21i plus 8i plus 6i squared. Remember, I squared is -1. And so we can combine the 28 and the -6, and then, of course, the i's. This will all simplify to 22 plus 29i. You should never have anything higher than I to the 1 power. Example 3 says, find the complex conjugate of 5 minus I. Use multiplication to verify your answer. So for a complex conjugate, remember, only take the opposite of the imaginary component. So if it's 5 minus I, we're going to make the conjugate 5 plus I. And then let's multiply them together. Let's see if it's actually the complex conjugate. If it is, that means our final answer will not have an imaginary component in it at all. So we get 25 plus 5i minus 5i minus I squared when we double distribute. And that I squared, of course, is going to turn into -1. So we're going to get 25 minus -1, which is really 25 plus 1, which is 26. So we have no more imaginary components. Therefore, yes, 5 plus I is really the complex conjugate of 5 minus I. So example 4 shows where we're going to use these imaginary numbers in real life. And one of the examples is of circuitry and finding impedance. R is going to be the element's resistance. X is the element's reactance, and that's the imaginary component. So we're going to have to do a little bit of substituting. So the actual impedance formula is going to be 1 over Z1 plus 1 over Z2, and then remember, those are both complex numbers. So I know this looks really confusing, but the Z just represents the complex number. So it says element 1 has a resistance of 10 ohms and a reactance of 3 ohms. So that's going to be 10 minus 3i. So as you can see, I have the Z1 and Z2 written down here. 10 plus 3i, 15 plus 2i. Now I'm going to put them into that 1 over z1 and then 1 over z2 because they need to be added together to find the impedance. How are we going to find a common denominator? Because these are two definitely different denominators, and on top of that, they're imaginary numbers. So the easiest way to find a common denominator if we're going to try and find the sum of these two numbers is just to multiply them. Okay, so we're going to do double distribution again. And after a little bit of work, you're going to get 144 plus 65i as your common denominator. Okay, and so now here are the two numbers written in terms of common denominators. Notice how I'm just multiplying by the other denominator. Just like if you were going to add 1/3 plus 1/4, you would multiply 3 times 4. You just kind of multiply by the two different denominators there. And now, since they have a common denominator, we can add the numerators together. You're going to get 25 plus 5i, and then, of course, over that common denominator of 144 plus 65i. And you know what? Go ahead and stop there, especially for Curriculum Engine. However, I'm going to say that having I in the denominator is not yet fully simplified. So I'm going to show you really quickly how to get rid of that I using the complex conjugate. So if we were to multiply the numerator and denominator by the complex conjugate, that would give us a real number in the denominator, and then it would be fully simplified. Now, I don't expect you to do this on the test. I don't expect you to do this on Curriculum Engine. In fact, they'll mark you wrong, I think, if you do it on Curriculum Engine. But this, when you get to upper level math, this is how you would simplify this so you don't have I in the denominator, because you're not supposed to have radicals in the denominator. Remember, I is really the square root of -1. So yes, it's kind of a lot of extra work. Yeah, and we're done. But there it is, fully simplified. So that's when you get to calculus. And you can say, oh yeah, Mr. Porter taught me how to simplify. And that's going to do it for this section. We'll see you in class.